Hi guys, this is Mrs. Allison, and today we are going to continue graphing sine and cosine, but this time we're going to take it just one step further and add the last two pieces of sine and cosine, and that is shifting it left and right and shifting it up and down. Okay, so let's get started. I am going to start by giving you the general form of trig equations. And what you're going to see is when we write this down, they are going to look very familiar to you, or should look familiar to you. A sine, we saw this before, A sine B. Now I'm going to add a set of parentheses that we didn't have before. Theta minus H plus K. Whoops, that just says K. Plus K. And then y equals, didn't leave myself enough room it looks like. The equal sign is huge. A cosine B, again parentheses, theta minus H plus K. I cannot seem to write plus K today. Okay, both of them are the same. Both of the equations are the same. The difference is what is in which trig ratio it is, so sine or cosine. And we looked last week at y equals A sine B theta and y equals A cosine B theta, but it didn't have that parentheses there. That parentheses is important as to where the B goes. For our purposes, this time, I'm just going to give it to you in the correct form already, so the B will already be pulled out if it needs to be. Otherwise, there won't be an H in there. But these are actually not that different than any of the other functions we've graphed this whole year. I'm talking they're not much different than our quadratics. They're not much different than our absolute values. They're not much different than our radicals. They're not much different than our, what did we graph most recently? Reciprocal functions, our log functions, our exponential functions. Really, they have similar characteristics. Now the wording is a little bit different when we get to sine and cosine, and we're going to look at that now. So A, we already know that A is the amplitude, so I'm just going to write amplitude. So we know A is the amplitude. We know that our period, to find our period, we are going to do 2 pi divided by the B value, okay? And I cheated just a little bit. I went back and typed those in because there wasn't enough room. So H is what we've used every single time in all of our problems. What does H do to a graph? Hopefully you said it shifts it left and right, and that is correct. Now, for trig functions, there is a specific phrase that they use, and they call H our phase shift. And it's really just a horizontal translation. It moves it left and it moves it right. Now, we're going to talk about what that actually looks like for our graph. I'm going to give you some shortcuts for that in just a minute. And then K, what do you think K is? That's right, it's our vertical shift. So this is a vertical shift of our midline. And the easiest way to do this, it's up and down. Obviously, that's what vertical means. And this K, we are going to shift the midline. And when we shift the midline, it shifts everything else. Everything else will fall into place. And actually, that's how we're going to use our graph. Okay? So let's look at a couple of examples. I'm actually going to walk you through quite a few of these to start with. So let's go through and start our examples. Okay, so the first example that we have is sine of theta plus 1. If you notice in this problem, the piece of information that we have is the K value. Okay, the reason I know this is the K value is there are no parentheses around the theta and the 1. There would need to be parentheses around that for it to be the H value. So this is actually my K value. So now let's go through and figure out what pieces we know. Okay, we know here that our amplitude, remember the amplitude is the number in front of the trig function, and since there is no number, our amplitude is 1. And then our period, remember our period is 2 pi divided by b. And since we don't have a b value in front of the theta, my period for this particular function is just 2 pi. Remember that what that means is that it takes from 0 to 2 pi to complete one cycle. Now, that 0 to 2 pi could change if there was an h value, but in this particular problem, we do not have an h value, meaning there's no shift left and right on this particular problem. But there is a k, and the k is a plus 1. So my k value is 1. Okay, I'm actually going to, let's do k in red, the midline in red. It will help you see it just a little bit. Okay, so let's look at what that looks like. What we know from our graph, or from the trig functions, is that if my amplitude is 1, what this means is it means that my max and my min are 1 away from, they're 1 above or 1 below the midline. So the key is we need to know where the midline is, okay? And since my k value is 1, it means that my graph is going up. It's going to start at the midline at 1. So the entire midline has shifted, okay? Now, my period is 0 to 2 pi, and remember when we deal with the period being 0 to 2 pi, we need the 5 numbers. So since I'm not shifting left and right any, one of them is 0, one of them is 2 pi, and then I need to find the 5 numbers in between. Well, I can go halfway between 0 and 2 pi, halfway between 0 and pi, halfway between pi and 2 pi, which is 3 pi over 2. So my 5 numbers are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, remember, this is a sine function, and remember in the sine function, the pattern is middle, high, middle, low, middle. Okay, so I'm going to start at the midline is my middle. When I say middle in each of these, I mean the midline. Now previously the midline was at 0, so it made it really easy. But now my midline has shifted up 1. So I'm going to start middle, then I'm going to go high, which is just 1 above, middle, 1 below, and middle. You'll notice that the distance between my midline and my highest or my lowest is 1. That's my amplitude. And now I can sketch my graph and draw nice smooth curves. We'll pretend it looks like it connects those dots. There we go, for my sine function. Okay, if you're really feeling brave, try the next one on your own. Hit pause, try it, and then come back. Okay, so hopefully you had a chance to try this problem. And there's a few changes, but really not many from what we just did. First of all, I see here that I do have a number in front of the cosine, which means that my amplitude is 2. That just means it's 2 above or 2 below the midline. My period, well, I don't have another b value, so my period is still 2 pi. And I don't have an h value because it's not, there's nothing in parentheses here. This would need to have parentheses for the 3 to be my h value. So therefore, my h value is still 0. And my k value, well, my k value this time is -3, which means I'm going down 3. Right? So the first thing I'm going to do is draw my midline down 3. So 1, there's my midline. And because I know this is a cosine function, I know my graph is going to start high, then go middle, then go low, then go middle, then go high. Okay? But high is 2 above the midline. So when I go to sketch this graph, and because, let's back up, the period is 2 pi, but I haven't shifted it anywhere, so it's the same 5 numbers I used before. It's the 0, the pi over 2, the pi, the 3 pi over 2, and the 2 pi. Those are my 5 numbers because the period hasn't changed. So when I go high, middle, high, I'm going to start 2 above my midline. Well, that starts me at -1. My midline is here at -3. My low is at -5. Middle, high. And although this looks like it could be a v, this is the cosine function. So it needs to look like a potential sine function has been shifted. So something like this. How'd you do? Okay, well, now's our chance to see what happens when we shift left and right. So we're going to start with that h value now, because I think k is a little bit easier, which is why we started with it. Okay, here we go. Let's look at what the h value does to our graph, okay? And then I'm going to give you 2 shortcuts that I think will help you when you need to determine your starting and your ending point. Before, it's been 0 to 2 pi, maybe changed up a little bit if the period changed, but now this shifting is going to totally throw everything into a loop. Okay, start basic. The things we know. The amplitude on this particular graph is 1. The period, well, there is no b value in front of this parenthesis, so my period still needs to be 2 pi. Okay, then I do have an h value. And my h value is, well, remember the formula says theta minus h, but this says plus pi over 4. So that means my pi over 4 is going to be a negative pi over 4, which means that my whole graph needs to be shifted left pi over 4. Okay, well, that messes things up just a little bit, so let's come back to that. K value, you'll notice the k value is 0, which means my midline, which means my midline is right here at 0. Okay, let's talk about that shift. There is one easy way to be able to get the shift and what it looks like in my problem, okay? And that is considering 2 equations. The first one is the starting point will always be represented by b, that's a b, times theta minus h, keeps trying to pull down my screen, h equals 0. That's my starting point. And then the ending point, I can use the same equation, b theta minus h equals 2 pi. This is going to give me my starting and my ending point. Let's talk about why. We know in my parent function, whatever I start at was, for sine and cosine, started at 0, ended at 2 pi. Okay, so if I take into account the period change, which is b, and the shift, the phase shift, the h, it will account for that in my starting and my ending point. Let me show you how that looks, and then I'll explain why it works with the idea of left pi over 4. Okay, let's see how small I can write this. Let's see if it'll show up. So if I start, I'm just going to put this down here. If I start with my theta plus pi over 4 equals 0, and I solve this, I get the starting point is negative pi over 4. Well, that makes sense because we shifted left pi over 4. Okay, let's look at how that affects my ending point. Okay, if I start with my ending point being theta plus pi over 4 equals 2 pi, and I solve this, then theta needs to equal 2 pi minus pi over 4. Well, then I got to deal with fractions. Okay, well, I know 2 pi is really just 8 pi over 4, and if I'm subtracting pi over 4, then my ending point is when I get to 7 pi over 4. Okay, so let's look at what that looks like. If I go and sketch a graph of this, if I go left pi over 4, that's going to be negative pi over 4, and I end at 7 pi over 4, well, I need to find the middle point of those. And if we count our spaces evenly, right, between the two, what's going to happen? Where am I going to end up at the middle? Well, hopefully you said 3 pi over 4. So 3 pi over 4 would be my middle point. And then I need to find the middle of those sections. And you can see that we have points at negative pi over 4, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay, so you might ask, how is it that the period is 2 pi? Well, if we look at the difference between negative pi over 4 and 7 pi over 4, there is a total distance. If we were walking the length of that, that would be 2 pi. It's just that it's been shifted to the left pi over 4. Okay, so what does that look like when we go to sketch our graph? When I go to sketch my graph, I'm going to start, and this is sine, so middle. Let's get a bigger. I'm going to start at middle, then go to my high point. It's only one up. Middle, low, and then middle. And then I'm going to sketch a graph. Okay, while this graph's not very tall, on this particular graph paper, that's just scale. Okay, so do you see how the shift happens? All right, I would love for you to pause the video and try the next example and see if you can get a good sketch of this cosine function. All right, hopefully you had a chance to sketch cosine, and let's look at what that looks like. Okay, so I'm going to start with my amplitude, and I don't have a number in front, so my amplitude is just 1. It's a really big one. And then I'm going to look at my period. Well, again, I don't have a b value in front of this, so my period in this particular problem is just 2 pi. My h. Well, my h in this case says theta minus pi over 2, but remember the formula has a minus sign in it. So my theta value is really just pi over 2, which means I'm going to the right pi over 2. And my k value again is 0. So we'll put it all together in a later example. But this right here is what I've got. So my midline is still 0. I can graph that in. My period is 2 pi, but there's going to be a shift in it. So let's go back and let's figure out what our shift is for this particular problem. So this says that my starting point would need to be theta, minus pi over 2 equals 0. That's a 0, believe it or not. Add pi over 2 to each side. That's pretty easy that theta would just be pi over 2. That makes sense. That would be to the right, pi over 2. My ending point, theta minus pi over 2, the littler pencil makes it harder on my fingers, is 2 pi. And if I solve for this one, I get that the ending point is 2 pi plus pi over 2. Well, 2 pi is 8. Nope, it's not. It's 4 pi over 2 when we're dealing with an over 2 part, plus pi over 2, which gives me a total of 5 pi over 2. Okay, so that means for this particular problem that if I start at pi over 2 and I end at 5 pi over 2, I need to find the middle points. Well, this one's laid out pretty nicely, that 3 pi over 2 pi and 2 pi would be my middle points. All right, now with an amplitude of 1, does it make sense now that my period being 2 pi is 2 pi from pi over 2 to 5 pi over 2? Hopefully the answer to that is yes. So this is a cosine function, so I'm going to start high. I'm going to go middle. I'm going to go low. And I'm going to go middle and then high. And so sketching the cosine function, totally missed that point, but we're going to call it good. Looks like this. How'd you do? Okay. Well, as you can imagine, these next two problems, there is a 4 in one of them. That's not how many we're going to do. The next two problems are going to be a little more complicated, have more of the pieces that we're looking at. So let's look at how that works. All right, here we go. So let's start with what we know. In this particular problem, I have an amplitude of 4 because there is a number in front. And in this problem, I have a b value that's in front of theta that is 4, which means when I calculate my period, it's going to be 2 pi divided by 4, which is pi over 2. Just a fun fact, this graph is actually really tiny on the particular graph that I gave you. I would have changed it for the presentation, but I just figured it'd be easier if they were all the same. And I didn't check before I already saved any. Anyway, I could have changed it. I didn't. Sorry. So let's talk about h values. The h value, there is no h value because there is no parentheses. So there's nothing there for my h value. So the nice thing is it doesn't have a shift left or right. Which means it's going to start at 0 and end at pi over 2 now. And then our k value. We do have a k value, and this time the k value is 1. Okay, so let's watch the process that I would go through to graph this. I would start with my midline at 1. So I have a midline at 1. And then I would deal with my period being pi over 2. Now I can go through those two sheets that talk about the starting and the ending point, but because I don't have an h value, I can do that. I'm going to show you in just a second how it works, but I could guess my way through the starting and the ending point, and here's what that looks like. If I need to start at 0 and I need to end at pi over 2, I have to have 5 places including those two, 3 places in between there. Well, there's really only 2 boxes. So that means I'm going to have a point at the pi over 4 and then halfway between and halfway between that. It's going to be a tiny graph. Okay, let's look at what that looks like. If we were to actually use the formula, and I'm going to show you why the formula is kind of wasted on this particular problem. If we were to look at the formula for this, I know that b, which I don't have, times theta minus h, that should say, needs to equal 0. So in my problem, I would have 4 theta equals 0, which means theta equals 0, because 0 divided by 4 is 0. And if I do my ending point, I would have 4 pi, that says theta, 4 theta equals 2 pi, and then I divide by 4, and I get theta equals pi over 2. So really, I haven't gained any information by using that. That setup of the starting and the ending point really helps when I've got a phase shift, when I've got that h value, not as much when I don't. Okay, so let's go through these points, and I'm going to keep it on the skinny pencil, so hopefully we can see it. This is a sine function, so middle, high, middle, low, middle. So my middle starts at 0 on the midline, and then goes high. Well, high is 4 up, so 1, 2, 3, 4, but it needs to be in the middle of that. Whew, it's hard to graph that with this pencil. Hard to graph that with my finger. Middle, low, down 1, 2, 3, 4. Middle, back here. So you can see this is a really skinny graph. It should start at 0. There really shouldn't be any over on this side at all, but I can't do that with my fat fingers on an iPad screen. So that's what the graph would look like. If you want, you could look at the annotated notes and see what it actually looks like. All right, if you're feeling brave, hit pause, try the next problem, and then come back and see how you do. All right, let's go through this, and I'm going to go through some of these steps just a little bit quicker. My amplitude is 2. My period, I'm going to stick with this skinny pencil for now. My period is just 2 pi because there is no b value. But there is an h value that has shifted my graph to the right pi over 4. It's a positive pi over 4, which means I'm going to the right. And my k value is -1, so I'm going down 1. Okay, so I may start with the k value of down 1. Okay, but now I'm going to go to my starting and my ending point that we looked at before. So theta minus pi over 4 needs to equal 0. That's my starting point, which means theta equals positive pi over 4, which is what we expected since it said write pi over 4. Now to figure out where it ends. I know that theta, because I don't have a b value, I don't have to worry about that. So theta minus pi over 4 equals 2 pi, means that my ending point is when I take 2 pi and add pi over 4. Well, again, I've got to add my fractions. So 8 pi over 4 plus pi over 4. My ending point is going to be at 9 pi over 4. So what does that look like? Okay, so if I'm going to end at 9 pi over 4, 9 pi over 4, and start at positive pi over 4, well, my pi over 4s aren't actually marked, but they are on here. My pi over 4 is this line right here. 9 pi over 4 is 1 pi over 4 above pi over 2. So it's going to be, oops, that doesn't look like it. It's going to be that line in between the 2 pi and the 5 pi over 2. And then my next point needs to come halfway between those two. And halfway between those two is right here in between the pi and the 3 pi over 2. And then halfway again, notice we've got all the lines that don't have actual values on them. Okay, well, this is a cosine function. And a cosine function starts high, goes high, middle, low, middle, high. And the high point is 2 above the midline. So high would be here. Middle would be the midline. Low would be 2 below the midline. Middle. High. And then I can sketch a graph. Now, this one I actually want to look at in just a second, because what I want you to notice on this particular graph is the distance between here and here. Is that 2 pi? And if the answer is yes, we know we shifted it correctly. So you could count if you wanted, you could do the math. This would be 9 pi over 4 minus pi over 4, which is 2 pi. But just check to make sure that it actually is a period of 2 pi. So how'd you do? All right, see, it's not much different than any of the other graphs we've done. H shifts it left and right. K shifts it up and down. It does have slightly different names, phase shift for going left and right, but otherwise it's the same as what we've done before. So your assignment now is to practice these, and hopefully you can do okay. Come ask questions during those optional office hours if you have questions. See you soon.